Hi everyone, welcome back to another wonderful day of mathematics. Today we're going to take a look at section 5.2, which is solving quadratic equations by graphing. I think you're going to find this section pretty nice because it's not any different from 5.1. We're just going to be looking to see where can we find some roots. So let's talk about our new vocabulary. We're talking quadratic equation, standard form, root, and zero tonight. So the idea here is when we're given a quadratic formula, and remember quadratic formula is something of the form ax squared plus bx plus c. Now what we're going to have is this quadratic equation, which before, last class we had this equal to y. This is now going to be equal to 0. And what we're trying to find are what are the values of x, which makes this happen. Those values of x are what we call roots or solutions to the quadratic equation. So as you can see from our pictures, when we go through and we graph these, you're going to have one of three options occur. Either A, there's going to be one real solution, so one spot where the graph touches the x-axis, or one spot where it gives you 0. You're going to have two real solutions, so two spots where the graph crosses the x-axis, or the graph is never going to cross the x-axis, which is going to mean no real solution. So let's dive right in. Solve x squared plus 6x plus 8 equals 0 by graphing. Let's switch it up to some purple here. So if I use what I did last class, same basic properties, same basic ideas. First thing I want to try to find is the y-intercept, which occurs when x is 0. So by plugging in 0 for x, we're going to see we get y equal to 8. So there's my y-intercept. Next spot we're going to try to look for is our axis of symmetry. And remember, the axis of symmetry occurs at a negative b, negative 6, divided by 2 times a, so 2 times 1. Which means negative 3 will be where the axis of symmetry occurs at. So if I put that line right down through, what that now gives me is an opportunity to take this point and reflect it over. So that should also be a point on my graph. Now, negative 3 is where the vertex occurs, so I would like to figure out what that is. So I'm going to take negative 3, I'm going to plug it in here for x. So negative 3 squared is going to give me 9. Minus 18 is now a negative 9, plus 8 more is going to give me a negative 1. So it looks like negative 3 and negative 1 will be my vertex. And let's get a couple additional points here. Let's try negative 2. So if I take negative 2 and I plug it in, this will be 4. Minus 12, which puts us at negative 8, plus 8, which gives me 0. So negative 2, 0, reflect it over, gives me this point right here. Let's connect the dots and draw our graph of our parabola. So there it is right there. That's what we did last class. Now, all we're doing here today that makes things slightly different is we're now trying to solve this equation. So basically, I'm finding out what values of x make this 0. And that means, when does it touch the x-axis? So it clearly touches the x-axis twice. Once here, and once there. And I can actually zoom in a little bit on those points. That didn't seem to go through there. Let me try that again. There we go. So if we zoom in on those points, you can see clearly it touches the x-axis twice. One spot seems to be at negative 2, and the other one seems to be at negative 4. And those are, in fact, the solutions to our problem. Negative 2 and negative 4. Now, we did just complete a factoring lesson not too long ago. For those of you who are factoring geniuses, let's notice that this does factor into x plus 4, x plus 2. And if I set each one of these equal to 0, so if I set x plus 4 equal to 0, that would give you the value of negative 4. And if I set x plus 2 equal to 0, that would give you the value of negative 2. So this is just another way of finding 0. So if you find out you're not a factoring person, you can always graph. If you're not a graphing person, you can always factor. There's lots of different options to solve here. All right, let's give another one a try here. Solve negative x squared plus 4x minus 1 by graphing. If exact roots cannot be found, state the consecutive integers between which the roots are located. Not every single problem that you're going to do is going to work out like the first one did. Not everything crosses that nice number. Sometimes it doesn't cross at a very good place. And we'll talk about different methods a little bit later on how to find the exact value of those. But for now, if it doesn't cross at an exact point, all we're going to do is we're going to give the numbers which we think it occurs between. So let's give this a try, and I'll show you what I mean here. So negative x squared plus 4x minus 1. Let's graph. So I'm going to make my xy chart, plugging in 0 for x to start off with, which means 0, negative 1 will represent my y-intercept. Next, we'll find the axis of symmetry. So the x-coordinate is a negative b, which is a negative 4, over 2 times a. So 2 times negative 1 gives me negative 2, which looks like our axis of symmetry is at 2. So I got a line running through there, which allows me to flip this point over. Let's find out where that vertex is. So I'm going to take 2 and plug it in for x. So 2 squared is 4 times negative 1 is negative 4. Plus 8 makes that positive 4. Minus 1 gives me 3. So 2, 3 would be the vertex. We get one additional point here, so we're going to plug in 1. So 1 squared is 1 times negative 1. So negative 1 plus 4 is 3. Minus 1 gives me 2. So 1, 2. Well, I clearly graphed that point wrong. Let me fix that. This needs to be up here at 3. And 1, 2, we'll put right here. Flip it over. Matches up right there. Connect the dots together, and there's my problem. Now, unlike the last one, this does not cross the x-axis in nice points. It does cross the x-axis. Clearly it crosses twice, so I got 2 real solutions here, but they're not nice. So in this situation, what I do is I simply tell where they occur between. So I'm going to say this has 2 real solutions, and they are between 0 and 1, and between 3 and 4. And like I said, eventually we're going to come up with a few different techniques for finding these exact numbers. But until that point, we're just going to list where do they occur between. Okay, let's do one more problem here. Let's try this one. Let's solve this by graphing. Now, the issue with this one is not everything's on the same side. When I solve these problems, I want to make sure it's equal to 0. So we'll go x squared minus 4x plus 4. Put everything on one side. Has to be equal to 0, just like factoring. Has to be equal to 0 before I can do anything. If I run through my steps, we'll go through this one pretty quick. Plug in 0, we're going to get 4 for y. Axis of symmetry will be your negative b, which is 4, over 2 times a, which gives me 2 for my axis of symmetry. I'm going to take 2, I'm going to plug this in for x. Let's flip this over first. Take 2, plug this in for x, so I get 4 minus 8, which is negative 4, plus 4, which is 0. Ooh, look at that. The vertex happens to fall directly on the x-axis, and if the vertex falls directly on the axis, that means you're going to have one real solution. And that one real solution is going to be right at that point. So when x is equal to 2. Let's plug in one more point just to be sure I graphed this right. So 1 minus 4 gives me a negative 3, plus 4 gives me a 1. So 1, 1. Connect the dots together. There's my parabola and my solution at x equals 2. Alright, one last thing for today's lesson. This is a long one here, but I like this because it shows you what technology is capable of. The highest bridge in the United States is the Royal George Bridge in Colorado. The deck of a bridge is 10,053 feet above the river below. Suppose the marble is dropped over the railing from a height of 3 feet. How long will it take the marble to reach the surface of the water, assuming there's no air resistance? This formula right here, negative 16t squared plus h sub 0, describes t as time in seconds, h sub 0 as the initial height above the water. So in my scenario, negative 16t squared, the h sub 0 is where the marble is dropped, which would be 1056. You have 1053 for how far the bridge is, plus an additional 3 feet from where the marble is dropped. And that should be equal to the height at any given time. Now, what I want to know is when will the marble hit the water? The water is located at a height of 0. So I'm simply solving this quadratic equation for 0, just like I did before. Now, these numbers are kind of big, so to graph this by hand, you're really going to have to change your scale a lot. However, I'm going to show you how this is to be done on a graphing calculator. For those of you who have a graphing calculator, pay close attention because this is very helpful. So first thing we're going to do is we're going to go to the y equals menu. And in that y equals menu, I'm going to type in my equation, negative 16. Instead of a t, I'm going to use an x because that's how the calculator takes variables. So negative 16x squared plus 1056. Now, before I graph it, I know it's not going to fit on my screen. So what I'm going to do is I'm going to hit zoom, and I'm going to come here to zoom fit. Oh, we went right past it. So zoom fit is a 0. And what that does is it takes my entire graph and it'll make it fit in the window. So I don't have to worry about zooming in and zooming out. It's all right there. So here's the scenario. Now keep in mind what's going on. We're starting at 1056. So this is the starting point of the marble. And this is the marble as it drops off that deck in relationship to time. So as time moves forwards, the object is getting closer and closer to the water. Eventually it touches the water. So we're looking for this point right here. Where does it cross the x-axis? Well, to find where it crosses the x-axis, if I go in the second trace, which is the calculate menu, the calculator has this amazing ability to find a 0, which is exactly what we're doing, finding zeros or finding solutions. So if I click on 2, it brings me back to the graph and it asks for a left bound. So what I'm going to do is I'm going to move this little blinky cursor, and I'm going to move it somewhere to the left of where my 0 is. So my 0 occurs here. So I got it on the left. That's called the left bound. I'm going to press enter. It's then going to ask for a right bound. So I then move the little cursor somewhere to the right of that 0. Press enter one more time. And you can see what the calculator is doing is it's getting a range for which to search for this 0. So it's going to look between these two arrows. Finally, it says take a guess. I'm going to put the cursor as close to that 0 as I can get. Now you can see it's not going to be perfect, but as close as I can get. Press enter one more time, and the calculator is going to find the 0. So if this marble were dropped from a height of 1056 feet, it's going to take about 8.12 seconds before it reaches the water. Pretty neat use of the graphing calculator. Feel free to use this technique if you have one. However, do make sure you know how to do this by hand because you're going to be required to do both. Tonight, take a look at section 5.2 self-check. Bring your questions from this lesson into class tomorrow. We'll review them and continue learning. Until then, have a good night.